Hello friends, it's Euler. Today we're going to solve this question, okay? And before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you, and help me to grow my channel. Okay, so now let's solve this question. So what is the question here? A particle of mass m, this is a particle of mass m, falls a given distance. That distance is z naught at time t naught. This time is given by 2z naught by z whole to the power half, and distance traveled by that particle while falling down is given by this equation. This equation gives the distance traveled by the particle in time t, right? And we need to show that this line integral from 0 to t naught of this Lagrangian L dt is extremum for these two values of a and b, where a and b are constant. Okay, so this will be extremum for these two values, so that's what we need to show. Right, now note the question and let me clean this. Let us consider this is the particle of mass m. It is falling downward. Okay, after time t naught, in time t naught, it falls a certain distance, that is suppose z naught, which falls in time t naught. Okay, and at for given time t, the distance covered by this particle is suppose this is the distance covered by this particle z. Okay, so in time t, okay, this z is given by a plus bt square, right? This z is given by a plus bt square, which is already given in the question, right? So distance traveled this is downward. Okay, let me write here downward. In time t is given by this equation. Okay, so now you see, let me give this equation as equation number 1. Okay, now in time t naught, that means when t is equal to t naught, okay, then it travels a distance z naught, which will be given by a. This t should be replaced by, this should be a t plus bt square. Okay, so now t should be replaced by t naught and t square should be replaced by t naught square. This is suppose equation number 2, right? Now you see kinetic energy, and one more thing also given, that also z naught is equal to, t naught is equal to 2 z naught by z to the power half. That is given in the question, right? So which implies that if you square both sides, then if you simplify it, then you're gonna get z is equal to half z into t naught squared. That's what you're gonna have. This is equation number 3, right? Okay, squaring this and simplifying, we're gonna have this equation. So hope you can do this simplification. Very simple, right? Now you see this line integral from 0 to t naught of Lagrangian L dt will be extremum. Before writing that, let me first find the Lagrangian. Okay, So Lagrangian L is equal to T minus V. T means kinetic energy, V means potential energy, and kinetic energy is given by half mv square. So here V means velocity. So here the here distance is z. So velocity will be its time derivative z dot square. Okay, z dot square. Just wait. So z dot square gives you the z dot is velocity, right? Z dot means dz by dt, right? That is what z dot. Okay, so here z is the displacement. So when it is falling in a straight line downward, so displacement and distance will be same. So hope you have understood these things. So and minus v, v is the kinetic energy, sorry, potential energy, Now you see, if you consider this point as a reference point where v is equal to 0, potential is 0. So when it comes down a distance z, then potential will be given by, potential energy will be given by mg z. There should be a negative because I have taken this point as a reference point where potential is 0, so it is coming downward. So that's going to be minus mg z. So hope it's clear, right? So now if you simplify this, then this L also we end up with getting half m z dot square plus mg into z, mg z, right? So now you see, hope you can see clearly this. Just wait, let me write this step here. So here we're gonna get L is equal to half mz dot square minus plus mgz. Okay, now you see, let's do one thing. We have got the L. So now you see, this line integral from 0 to t naught of L dt is extremum. If it satisfies this condition, right? If you see, del L by del Z minus d dt of del L by del Z dot is equal to 0. If it satisfies this equation, then this will be extremum, right? So now you see, let's find del L by del Z. Okay, so this is our L. So if you differentiate it with respect to Z, then here this is partial derivative. So if you differentiate this with respect to Z partially, then this Z dot should be taken as constant, so this terms become 0. So here we're gonna get mg dz del Z by del Z, that's gonna be 1. So del L by del Z, that's gonna be m into z. And next let's find del L by del Z dot. If you differentiate this partially, with respect to Z dot, then you should consider this Z as constant, then variable will be Z dot because it is partial derivative. If you differentiate this, so then what you gonna get? If you differentiate, let me show you here. If you differentiate this half mz dot square, if you differentiate it with respect to Z dot, then half into 2 into m z dot, you're gonna have 2 to cancel, so you're gonna have mz dot, simply m into z dot, right? Hope you have understood this. Now you see, here we need the time derivative of this. So what will be its time derivative? So if you differentiate this with respect to time t, right, then mass is constant. If you differentiate it again with respect to t, then it's gonna be z double dot. it's gonna be z double dot, right? So hope you have understood this. Now using these values in this equation, let me take this equation number 4. This is suppose equation number 4. Using this results in equation number 4. Equation number 4 implies, so del L by del Z, that will be replaced by mg minus, and this term will be replaced by this value mz double dot, mz double dot, and equal to 0. And this implies if you divide each and every term by m, here g, here z double dot, and 0 by m, that's going to be again 0. So we're going to get g minus z double dot is equal to 0. And if you simplify this, if you shift this one on the other side, then your g going to be equal to z double dot, right? Z double dot, that's what we're going to have, right? Now you see, this is suppose equation number 5. Now if you differentiate this equation number 1 with respect to time t twice, then what you're going to get? If you find z dot, then from this equation, then you're going to get a plus b 2t, sorry 2bt, that's what you're going to get if you differentiate it with respect to time. So here you can write differentiating equation 1 with respect to time t, right? And if you differentiate it again with respect to time t, then you're going to get z double dot, then this is constant, that's going to be 0, and here we're going to get 2b only, then we're going to have 2b only, and z double dot is nothing but g. So this implies g is equal to twice b, which means b is equal to g divided by 2. So this is the value of b that we have already got. If you see the question, so we need to show that b is equal to g by 2, and we need to show a is equal to 0. Now let's prove a is equal to 0. So now let me give, this is equation number 6. Let me take this equation number 6. Okay, now I'm going to clean this board, and I'm going to keep the required equations only, which are essential to prove that a is equal to 0, right? So now let me clean this. Now you see, from these two equations 2 and 3, from equation number 2 and equation number 3, we get what we're going to have here. We can replace this z naught by this value of z naught, then what we're going to have, then we're going to have half z t naught square is equal to a t naught plus b t naught square. Now you see, half z t naught square a t naught b, this t naught, this b can be replaced by g by 2. This b can be replaced by g by 2 t naught square. So we have used equation number 6. Using equation number 6, or just you can write putting the value of b. Okay, z by 2, that means you can write this way, half into z into t naught square, right? So now you see, these two terms cancels, half z t naught square cancels. So this is a t naught is equal to 0, right? So here t naught cannot be equal to 0, because already it is mentioned in the question that in time t naught, z naught is the, the distance falls by this, an object falls at distance z naught in time t naught. So here this t naught cannot be 0, right? So that's why the only possible thing which can be 0 is a, since t naught is not equal to 0, right? So this is the value of a. So if you see the question, we need to show a is equal to 0 and b is equal to g by 2. That's what we have done. Okay, so thank you for watching. See you in the next video. Bye bye, take care.